Hello and welcome to York Universe, the astronomy and astrophysics radio podcast written and presented by the students, faculty, alumni, and friends of York University. That's right, you'll now find us wherever podcasts are distributed. So, welcome to the new era. I'll be one of your hosts this evening. I'm Dr. Elena Hyde, and I'm joined tonight by one of our regulars, now turned extra special co host, Mary Helen Armour. Great to have you back. We are broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. York Universe broadcasts every Monday night at 9 p.m. local Toronto time live on YouTube with our online public viewing team. If you want to go ahead and join the live streams, join in on the fun, you can always find us through our website, yorku.ca/science/observatory. And you can follow the links to OPV, online public viewing, or click on any of the links on that site that say YouTube. You can also, of course, email us if you have any questions or comments or suggestions for future topics at observe@yorku.ca, and connect with us on Instagram, Yorku Observatory, and Facebook at Ellen I. Carswell Obs, because we're on some of the social media still. And of course, all of our programs are free. But if you'd like to make a donation, you can always see that same website again, yorku.ca/science/observatory. We'll be monitoring the chat room for questions during the live broadcasts and posting content. Again, that's only at the live broadcast that's in conjunction with OPV over on YouTube, so don't get too confused. And that's at 9 p.m. Eastern Time or 2 a.m. UT ES. That is more your speed, I suppose I should say. Well, it looks like it is another cloudy night in Toronto, so we're not going to be able to open up the telescope tonight, but we can hope for clear skies later. How does it look where you are, Mary Helen?
It's cloudy up here too.
Nice thick layer.
Yeah. So not like a couple weeks ago when you were able to see northern lights and it was nice and clear. So
Yeah, we've had some unseasonably warm weather, and it seems to be bouncing around a bit, which is not, I think, helping with the cloud layer. I've been watching this week, and I think at the moment, Thursday is probably our best chance in Toronto for getting to see past the clouds.
yeah, when it starts to get cold again.
Yes,
When
exactly.
everything clears up.
Yeah, and I suppose, additional warning for any astronomers about who haven't checked their watches recently. But we did just have daylight savings time as well, so of course, watch out with your rise times of any of your objects out there, I suppose.
But your
Um,
programs will do it for you automatically if you use one of the.
That's true. If you do have an automatic system, yeah, just make sure your clock's connected to the internet and hopefully it'll sync up. Those are easier, absolutely. And we have a pretty fun program for tonight. We're going to be traveling all over all kinds of things. Now, I think we've got plenty to go through in this week in space and astronomy history. It sounds like you have a really interesting one to start us off. So why don't I let you go first?
Yeah, I think we decided to look at a whole bunch of different missions, and of course, most people know the space missions started in the late 1950s, and it was actually the Russians who got up the first two. And the second of their successful early satellites, Sputnik 2, launched November 3rd, 1957. So that's uh almost 70 years ago at this point. So
Wow.
that's how long we've been in sort of the space era. I believe Sputnik 2 was also the one that carried the dog Leica, so it was the first
Oh,
animal that
so
went into
sad.
space. Yeah. Uh, but that's sort of, that's sort of this week in astronomy. And we don't think of it much as satellites now because we're so used to seeing them overhead all the time. And, but at the time it was, I think, shatteringly different and scared a lot of people that the Russians could put satellites into space well ahead of the Americans, because the Americans had some spectacular failures at that
Oh
time
yeah.
trying to launch. So they ended up sort of behind the Russians at first because they got Sputnik 1 and Sputnik 2 up so successfully at that time.
Yeah,
Mm.
absolutely. And of course, the Sputnik crisis. If you really want to see some, I mean, we complain about the news today, but if you want to see some absolutely, I don't know, hyped up, terrorized people posting all kinds of crazy things in their newspapers, the Sputnik crisis was, there's some pretty amazing stuff in there. They had no idea what it would mean and what kinds of things could go up there. I mean, of course, there was initial proposals that they were going to put up mirrors that were going to reflect enough sunlight back to like burn parts of Earth, and um, it was just because people didn't really understand how a lot of it worked. Um, there was a real crisis reaction, and I think there's something over 300 or so articles of something like 11 articles a day between in the month of October. And I think you were saying Sputnik 2 was, what year was that again?
1957. I think it was only a
Yeah.
short while after the first one. So
Yeah, and that was October 1957 that they had the sort of big
panic.
Sputnik panic. Yeah, basically War of the Worlds, but Sputnik.
Yeah. Well, of course, that's also the era of the Cold War, and you had nuclear weapons by this point. So that was the other big worry that you could put something like this on a space platform, uh,
Yes,
and
exactly. And I mean,
weaponize
it was
space.
a real, yeah, a real risk because once you had things that could go up, how could you defend against that? And it was not at all clear that, you would be able to. And so there was a real worry that there would be some sort of new nuclear war.
Oh yeah,
Um,
the space race at that time was quite a I don't think we can understand it because we're so used to space stuff, but it was socially a huge shock at the time. Um,
Yeah, well, I highly recommend folks who do like to read, whether it's fiction or science, or science fiction, to read some of the stories that came out, before, during, and after, because a lot of them were serialized into sort of little mini science fiction stories. And I'm a big fan of, of early science fiction, so I have maybe read more than my share, but I would just give a little shout out to Robert Heinlein, who wrote
oh
a
yeah.
ton, especially about a lot of those very same topics. He was very pro space exploration, but also really, really worried about World War III because he had seen World War
Yeah.
II before, during, and after. So there was a real I suppose, a real concern at that time, and a lot of his stories reflect that. He's got a great collected works, highly
Oh yeah.
recommended.
Oh, I've read a lot of Heinlein over the years, and
Oh,
probably
am I mispronouncing it? I'm sorry.
yeah, I know. I
Heinlein.
Heinlein, I don't
As
know.
I see it and I pronounce it in my
Yeah.
head. So,
Yeah.
but yeah, excellent, excellent stories. And I mean, the great thing about it is, it's all speculative. But I don't know if you've seen the one, and this is science fiction, and actually goes all the way through to politics because he's the one who testified before Congress several times to try to save the um, the space program.
Oh yeah, he was
And
quite involved with some of that.
yeah, exactly. And he did seem to get pretty disillusioned about it in his later stories. Um, but one of his last stories in his collected works goes back through and gives commentary from later on in his life, I think in the late 70s, or maybe even, yeah, late 70s, when he was quite old, about stuff he'd written before. And he does a wonderful recap and says, rather, after telling you all these pessimistic stories, I'm going to tell everyone a completely pie in the sky, over the top, optimistic story. What could we do to fix all this stuff? And of course, all this stuff being the lack of the space program and many other things that we will not go into because this is an astronomy show. But his pie in the sky solution was some sort of accident that I won't say anything about, but basically removes all the government of the time except for like one lower down person who then takes over and rebuilds the US government. And the thing that makes it work is that the person who does this is a black woman and not
Is
one
this
of the established
is this a foreshadowing given this
I
week's
don't know.
events?
I just thought it was quite funny because I have the collected book and I was like, they say science and science fiction are not meant to be predictive, but they are sometimes very interesting to read nonetheless. And of course, Sputnik being sort of the catalyst for this whole Sputnik crisis and hundreds and hundreds of articles, some of which very, very panicking, some very realistic. Um, and of course, Sputnik 2 having, of course, the really sad story of the dog on top of it. It does sort of all come together with, um, sort of you can't separate what's happened and gone before from the space program now.
Oh yeah, I mean it was very much born of politics and the Cold War rather than a real strong interest in science, although the science came along with it, which I think you get into for your next bit of history. But
I do. So I
it's
can get us to our next. We can keep going through history and space. And it is worth thinking about that these systems they're always so much more and so much more in so many different ways than what you could ever read about in any one history book, which is why I always recommend, read the books and the science books and the history books, and also read some science fiction on the side because you'll get a whole nother extra set of perspectives from it. And nothing inspired quite so much science fiction as Mariner 10. And I would go as far as to say is that nothing destroyed quite as many science fiction stories as Mariner 10, because people had really, in the early 1900s, 1920s, 1930s, people were really hoping for life on Venus and Mercury, but especially Venus. And Mariner 10 was launched in the 3rd of November, 1973, and it did amazing things, but it really disappointed a lot of science fiction writers. So this was an amazing mission. It's one of my favorites. Mariner 10 was the first mission to employ gravity assist, which has since become such a standard mode that we almost don't have to explain it anymore. But it's the idea of using the gravity of a planet to slingshot or basically change a spacecraft's speed and trajectory. So this is a way to make your spacecraft speed up that will not cost you hardly any fuel. And so you can speed up, you can change trajectory, you can basically do this trick where you go around and around and build up speed in various different ways. So Mariner 10 was the first one to employ this very cool bit of math. Highly recommended for any undergraduate students to go ahead and do this simulation because it's really fun. Um, and it flew by both Venus and Mercury. It did a whole bunch of pictures. It collected a ton of data. And interestingly, it was the first spacecraft to ever see Mercury, the planet Mercury. Not that far away, all things considered, but we had never had anything near Mercury before, and we didn't go back for more than 30 years
yeah.
after Mariner 10. Mercury, actually, and a lot of folks don't realize this, has remained hugely unexplored until very recently. Mariner 10 actually revealed that Mercury has some very strange components that people weren't expecting. It showed the surprising magnetic field of Mercury, because why would such a small planet have such a strong magnetic field, and why would it have a metallic core that makes up apparently 80% of Mercury's mass. So basically, Mariner 10 it flew past Venus and very much discouraged anyone with the idea that there could be life on there. Um, so, Venus, as we know today, is extremely hostile to life as we know it. Julie Tomei would say that the best description of it is that if you were to go to Venus, you would be crushed down to the size of a tuna can. um, and this is something that all little kids like to picture. Somehow it's very fun. Don't go there. It would not actually be fun. The atmospheric pressure is only the least of your problems because it's also acidic. It's also extremely hot, and it is just a very, 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 very
Yeah.
hostile
Yeah,
situation.
I still remember one video that early on, it was Andrew Franknoy, he was one of the narrators for the series, and he used to call Venus Earth's twisted sister.
Yeah,
And it said basically you have your choice of being squished, baked, or acid dipped. If you
yeah,
penetrated into
yeah.
the atmosphere, it was a question as to which would kill you first.
Yeah, and it was such an interesting mission and such an interesting set of discoveries with Mariner 10. I mean, it did have a lot of difficulties to overcome because going past Venus is relatively safe as long as you don't get too close. To get past Venus, they basically had to just make sure that trajectory wouldn't go too close or too far away, such that the critical point near Venus wouldn't cause it to, for example, crash into the planet or send it flying off. So this is the thing you have to worry about with gravity. And the Mariner 10 not having any sort of sister spacecraft. So usually back in this time they were launched in pairs so that if one failed, there would be a backup. But at this point, they had started to cut down the budget so that basically, if Mariner 10 failed, NASA would only allow the backup to be launched if the fatal error was diagnosed and fixed. So they really had to make Mariner 10 actually work, and it did complete about, I think, 7 experiments at Venus and Mercury. And it had a set of instruments that we might not necessarily recognize today. I would be interested to know of how many of our young listeners can picture television photography. But basically, it had an old-fashioned TV camera. I mean, I think this is 1970s we're talking about, and the resolution was something like 800 by 700 pixels.
Yeah.
So
I mean,
small
tiny
resolution.
by comparison.
Yeah, it's small resolution, tiny camera. We only got about 7,000 photographs back because the cameras consumed so much energy. It was very, very, very difficult to get actual pictures back. But we had other instruments that were a little bit easier to get information off. So we had something called a radiometer, which could detect infrared radiation and find out how hot things were. So it was designed to measure temperatures as cold as negative 193 Celsius and as hot as 427 degrees Celsius. So it's a good thing they included a wide range because turns out they went off to measure some of the hottest and coldest. So obviously the cold side of Mercury is pretty cold. But yeah, the
Yeah.
cruise to Venus was extremely eventful, and the trajectory correction maneuvers that they had to make. I would just recommend anyone to go and look at the diagrams that they had to use for these trajectory calculations. They're beautiful, incredibly complex, and the Venus flyby was the first mission, as I say, the first to actually succeed at broadcasting images back to Earth. And unfortunately, it was not full of giant plants or dinosaurs or anything else.
Oh yeah, I
It's
mean a lot of
full of
yeah, a lot of the sci-fi writers at the time were thinking, dinosaur swamps and, hot steamy jungles, and it was sort
well,
of a
it is
total
hot.
it is hot.
It is hot. Um, but
Nothing
yeah,
else was quite the same.
yeah, exactly. And they as I say, it's finding out just how hot and how cold Venus and Mercury really did get. So the hot side of Mercury versus the cold side of Mercury. And I think while Mercury was going around, Mariner 10 flew by actually twice in its orbit. And it did get a range of different distances, but it sampled such a small part of Mercury's total surface that there was still a lot to be discovered. So it's just a wonderful mission, and of course, a wonderful little time in, I suppose, space and astronomy history.
Oh yeah, I
Uh,
mean the whole Mariner series was fascinating. I mean, a number of them were unsuccessful in the early days of space flight, but of course Mariner 4 was the one that flew by Mars a number of years
yes,
earlier and sent back
yes,
another massive disappointment to sci-fi writers that Mars was
yeah,
not
yeah.
yeah, no, sorry, no Barsoom. Um so
It
massive
is
disappointment.
substantially more extreme than humans were currently imagining. But so was the moon, so that only fair. It just the moon we were able to get details for a little bit sooner.
Yeah. So
Um, but anyways, of course, as we go through space and astronomy history, sometimes science fiction writers are disappointed, and sometimes they're pleasantly surprised. So
so
you just never know. And we do it to discover things, and it is still amazing to me the things that we have discovered by going to Mercury and going to Venus with Mariner 10, and of course going to, as you say, Mars are stranger kind of, I like to think of it as stranger and more wonderful than fiction because we just couldn't have made this up. It's too amazing. Um, Speaking of things that are amazing, I think your next mission,
Yeah, I mean, going through that, the missions we talked about, the Mariners and Sputniks, you're talking inner solar system, but of course the Pioneers were
yes,
launched in the early 70s as well. And Pioneer 10 sent back the first images of Jupiter in, first November 6, 1973, and that was another huge one. It's like now we had up close pictures. Now, obviously Jupiter seen a fair bit of it through a telescope, but again, 500 images of Jupiter were sent back and gave us the first sort of real detailed look. Some of these pictures, I think, also included a bit about the various moons, although it was more the Voyagers that looked at those. The Pioneer missions, I think, something that, to this day is kind of interesting to remember is the Pioneers to this day were still some of the fastest spacecraft we've ever launched. Uh, Pioneer 10 made it to Mars in only 3 months, right?
yeah,
You think about now where we launched them and they take 6 to 8 months, and this is like decades later. The Pioneers were launched on incredibly powerful platforms. They're still some of the fastest spacecraft ever put into space. And this is, 50 years ago now that these were launched. Again, it's like I think what fascinates me too is when you look at Pioneer 10, like many of these space missions, they have sort of a lifespan. In case in Pioneer, it was like 21 months. And yet they stayed in contact with it until I think it was 1997. So it seems like these missions are either spectacular failures or so many of them last much, much beyond the original time frame, and we keep getting data back from them. Now, of course, technology launched in the early 1970s. By the 1990s, you're way behind, but you're still getting some data
yeah. And
back.
actually, I'll revise your number just a little bit because it was actually all the way through to 2003 that we had some radio contact with Pioneer 10.
Oh, okay.
So you're absolutely right. It just kept on going, which is awesome. And the thing is, like, there once I think scientists and engineers realized how extreme going into outer space was, they started to build things extremely, well, sturdily with this incredible environment in mind. And when you start building in, quadruple redundancy and things like that, yeah, I guess, if you do get lucky and nothing crashes into you,
It can go for a long time.
yeah. Yeah, and it is also interesting to note that their batteries are a type of nuclear battery, right? This is a atomic or nuclear battery that uses radioisotopes to generate electricity, which is extremely long-lived. It has no moving parts, and one of the reasons why these crafts just keep going and going and going are because of these nuclear batteries that were launched with them. The I believe the plutonium uh, has a half-life of 87 years or something. So I'm not sure what I haven't done the calculations to find out what the actual absolute maximum would be if we hadn't have lost radio communication. But still, compared to the lithium ions that we have in our phones that die every night when we come home, um, it's a whole different ballgame because this is lasting for decades.
Oh yeah, I mean the radioisotope thermal generator RTGs, because it's not I mean I guess what people sometimes get confused, it's not actually a nuclear reactor.
Yeah,
They're
it's not
using
a
the
reactor.
heat, yeah, they use the heat of the radioactive decay to generate electricity. So it just keeps going and going and going, and it's really quite spectacular. And of course, with the Pioneer missions and later the Voyages, the things I always remember are the messages to outer space that
Oh,
Carl
yes.
Sagan, particularly with the Pioneer 10 and 11, the gold plaques that he was involved in creating, and it's still heading out there,
Yep.
So who knows if something will eventually pick it up and
Yeah,
be
I
able to
mean,
decode
space
those.
is big, but if it doesn't crash into anything, it could keep going for, I mean, in theory, longer than our star. It could just go to another galaxy and really confuse someone someday.
Yeah, because if nothing stops it, it just keeps drifting along. So, but
Exactly, exactly. And that's, I mean, Pioneer 10, like Mariner 10 before it, or at the same time. Wait,
yeah,
yeah,
they were
3 days, three
simultaneously
days,
mission. Yeah, they were simultaneous
3 days
missions.
before it. Yeah, they both were putting out really incredible results. And I mean, I would say that as much science fiction as they discouraged, they definitely encouraged, at least at times more, once they had started sending back their first images.
Oh yeah, it's interesting to read the science fiction from like the 50s to the 60s to the 70s and see how authors sort of pictures of the solar system kind of changes and how they reflect on potential life in the solar system as you progress. I mean, Arthur C. Clarke in his whole Space
Yes.
2001, and the idea of I guess in one of the later ones, Europa being seeded for life is, really stems out a lot from what was found in some of these early missions about Jupiter and its planets. So
Oh yeah. Well, and I mean, the Europa Clipper is still
it's on its way.
uh, yep, yep. Europa is still one of the most interesting targets, I think, in the solar system. Since its first discovery, just the fact that it does have definitely so much liquid water. Um, and I mean, exactly how much is not entirely known. How exact thick is the ice crust? How exact thick is the core? But it's a lot of liquid water any way you dice it. And it definitely has heat with the tidal heating. So, Yeah, I hope it gets there and does all kinds of great stuff.
Yeah. Well, the thing is, the Europeans also have Juice on the way too, which is not quite
Yes.
so focused on Europa. It's focused on all of the icy moons, but it will be interesting to see what this combination of missions brings. But what's really fascinating, if you look at it, is they're going to take like much longer to get there than the original Pioneer and Voyager missions by
Yes.
comparison. So it's kind of interesting to see how, the space travel thing has changed, because now you're talking 5 or 6 years to reach Jupiter, whereas with the Pioneers, you were talking, I think it was less than 2 years to get there. So it
Yeah.
shows you the difference in the speed at which some of these missions now move.
Yeah, and the also the difference in propulsion as well. Smaller, slower propulsions that utilize more gravitational slingshots make for potentially smaller payloads to launch. And of course, the extreme miniaturization. I mean, obviously, the cameras we have now are so much smaller than the camera they had to
CCDs.
launch. Yeah, we have CCDs now. It's amazing. We don't need to use the videographic broadcast camera from Mariner 10.
Yeah. So it's the technology has changed so
Yeah, and
much.
yeah, exactly. And it is much more centered on miniaturization and I would say um, smaller batteries, but more variety of equipment. Although if they do try to put an actual submarine on Europa,
Yeah,
it's
that one has so many complications
that's going to be
because,
a tough one. Yeah,
yeah, not just technical challenges, but there are also ethical issues, because if you don't disinfect it perfectly and you
yeah.
carry any earth bacteria that are hardy little things, um, you could wipe out potentially any European life, because these would probably be a much hardier version if they've, earth-based bacteria are some nasty customers in some case. And,
Oh
it's
yeah,
that's
yeah.
why
And
that's
it's
why they
how would you put a submarine without and have it completely disinfected first? You'd need to have some incredible clean room, like I don't know, in orbit or something.
yeah.
Um, but we don't have one, so that's probably good for now.
That's why
But
they that's
yes,
what Yeah, that's why Galileo was crashed into Jupiter, because they didn't want to take
yeah,
the risk of it landing somewhere like that with the
accidentally crashing on,
potential.
yeah.
Yeah.
Yeah, I mean, we didn't want to risk it accidentally crashing on Europa or Ganymede or even Io for that matter. I mean, it looks like it's just volcanic, but you never know. So, into Jupiter it went. And it is worth noting to folks who are interested in watching the JUICE mission, the website. I believe they are still doing live updates of its mission progress on its way to Jupiter. It's following the gravity assist as first done by Mariner 10, and you can actually see how many trajectories it's going on. So you have little orbital paths where you can see where it is, where it has gone, and where it's going to. So you have the Sun, the Earth, the Venus, and then Jupiter, Ganymede, Callisto, Europa around Jupiter. And the JUICE orbital path is what it's doing is it's taking it around sort of the inner solar system several times, and then eventually it's making it out to the orbit of Jupiter. And when it's out at Jupiter, then it's going around different orbital paths so that it flies past Ganymede, Callisto, and Europa. I don't think Io is on the list though.
Yeah, I don't think it is, right? They were the set of instruments you need for IO, because of the different surface conditions, would be quite um different than what you'd need to study the icy surfaces. But yeah, the
And the
juice,
radiation is quite
I
high
just
there.
pulled it up quick. Yeah, the juice mission, or the juice mission still does show its plot, if you look online and search the mission. So right now it's actually relatively close to Earth. It's only 0.17 AU away. It's right in sort
It
of, I guess, one of its
Yeah,
booths.
it is. And so this is actually a fun thing that we can watch for from the Allan Carswell Observatory, because we have had some experience tracking, for example, James Webb Space Telescope in its orbit. We can, and any telescope that has reasonably good satellite tracking can try to find JUICE as it does its next flyby. So JUICE will have a flyby of Venus next year in 2025, and then it's coming past Earth on a closest approach in 2026. And then it's coming past Earth again on a closest approach in 2029 on its way out to Jupiter, where it will finally get into orbit with Jupiter in 2031. So
Yeah.
talk about a long time scale.
Yeah, it's doing a whole tour of the inner solar system before it heads out. Uh,
And actually, this will get me to my next topic. One of the reasons why it's so slow, and not only is it does it have a very small little propulsion system, but it was only launched with an Ariane 5 rocket. And if I go back to Pioneer, Pioneer was launched with the much larger, or at least Pioneer 10. I'm not sure all the Pioneers were launched with this, but I think most of them were. The Atlas Centaur rocket, which was basically a giant, Atlas Centaur, Atlas D missile SM-65, and these launched from Cape Canaveral, and they were expendable launch vehicles that were fairly hefty, at least compared to the little Arianes. Well, I say little, not the smallest ones, but um, it is worth noting that, of course, as we've seen recently, the ability to carry different payloads into space is also really significant for what you can launch. So the recent return to the SLS with the Artemis program for the moon, for example, having a heavy lift vehicle again.
yeah, that was part of the development that SpaceX has tried to put in to build a heavy launch
Yes, and they
rocket
have they
too.
have their own. And I think, as you mentioned before, it is worth noting that at some point the really really big Saturn V's, those were I think those still have never been beat in terms of their
No,
capacity.
no, they're still the
And
biggest ever.
they are, and we've seen you know uh, uh, you know several iterations on down, but sort of trying to replace them with the space shuttle meant that we didn't really have that massive Saturn V capacity. And the Atlas, just to put it on comparison, if I was to maybe make a line, Saturn V would be kind of on the heaviest lifting end, and Atlas would probably be somewhere in the middle, and Ariane would be at the sort of bottom end with the little Soyuz rockets.
Yeah.
So just in case anyone's a rocketry fan, that would be my rough scaling.
So,
All right, so we do have a couple more fun little history facts. I think we have time for maybe one more, but since I've started us talking about rocket launches, I've cleverly gone from rocket launches to a launch facility. And it occurs to me that we talk a lot about, the Saturn V's and maybe even the Delta Heavies or the Atlas rockets and the space shuttle and launching from Cape Canaveral. But there are other launch things out there. There are other launch facilities. There are other countries launching, and actually, there are more and more other places with launch capability. Of course, we've seen recently the Indian Space Agency do amazing things. Japan, China, obviously Russia is still doing great stuff. But we don't talk nearly enough about some of those. So I thought I would do a little This Week in Space and Astronomy History, going back to 1971. So again, keeping it, I don't know, very 70s. The 5th of November, 1971 was the first launch from the Guyana Space Center of the ELA 1 and ELV. And this is a little bit of French practice for me. So this is Ensemble de Lancement Vega, which was the Vega launch complex. And this is at the Guiana Space Center in French Guiana. And it was supporting launches of Vega and Vega C rockets. It was first built in 1971, but it actually had been used to support launches of Europa, Ariane 1, and Ariane 3 rockets. So the Guiana Space Center is used by the European Space Agency, I think pretty much exclusively, and the French government, and it launches satellites into space. So if you did not know about the Guiana Space Center, I recommend everyone look it up. So it's actually located near Kourou in French Guiana. And they started launching the first satellites there with the French government in 1964. They offered to share it with the European Space Agency when the European Space Agency was created in 1975, so some years later. The ESA, or European Space Agency, so the ESA now contributes about 2/3 of the spaceport's annual budget. So they now launch for all kinds of places, and they actually have some support for launches from the US, Japan, Canada, India, and Brazil. So we might know it's for Canada. It's good to know that we can get some support there. And actually, I should have been able to find this, but I'll leave it as a little question for anyone in chat who wants to go see when was the last Canadian launch from here. I couldn't actually find it in there. So French Guiana and at the Guiana Space Center. So this has got obviously a bit of history on it as well. This all started back in 1962 when the French Space Agency wanted to look for a site close to the equator. So if you are launching from the equator, you actually get a little bit of a boost from Earth itself to help you get off the planet. So you do get a little bit of an advantage if you're closer to the equator with your launch, which is why most launch centers are semi-equatorial. Cape Canaveral is not too far. So um, they were looking for a good place, and the prime minister at the time, which was Georges Pompidou, he officially chose Guyana because of its access and that there was some infrastructure that they could use. So the first mission was in April 1968, which had a liquid propellant French Veronique sounding rocket, which was, a little bit, if you can just imagine it being a little old-fashioned, it actually really is. And other missions started to follow, and they had eventually what would become the Ariane series. So this was actually, some of the rockets that are still used today. And the Ariane initially operated from the ELA-1 launch complex, that complex I mentioned. They started launching Arianes from there in 1979 and all the way through 1989. And now they're repurposing for the new or newer model of Vega lighter rockets. And they had EL2, which was basically just a similar facility, but launching Arianes a little more frequently. So several hundred launches of Ariane rockets, and they've now started a sort of third chapter, ELA-3, for heavy lift Ariane 5, which are still much smaller than what we would think of as heavy lift if you were going back into history. So the program is still ongoing and is well known for launching all 5 automated transfer vehicle cargo ships to the International Space Station between 2008 and 2014. And Arianespace's medium launch Soyuz rocket also has started operating at Guyana in 2011. So a space launch center with a long and glorious history, which had its first ELA-1 and ELV/ELV launch 5th of November 1971. So again, the 70s being a very active time in some ways, although a lot of stuff was getting dialed down. So maybe a good reason to go to French Guiana sometime. Go watch a rocket launch. Um, I've never been. Have you?
No. So, anywhere in equatorial, though, has to be warm and tropical, which with the weather starting to change here in Canada at times seems very appealing.
Yeah, right. I think in about a month and a half, it will be very attractive. Um, so, yes, it is. It is approaching the slightly colder part of the year. So, yeah. Anyone planning a vacation, maybe yes, definitely think about it. Maybe time it so that you get to see a launch while you're there. And we do have one extra bonus item. I think we'll probably have enough time to do it. But actually, let me go ahead and do the sound bites just because we are a bit over halfway. All right, everyone, this is about the halfway mark, and you're listening to York Universe, broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. You can find us at www.yorku.ca/science/observatory. You can check out the chat, ask questions, and of course, see all of our fabulous content. Tonight, you're listening to Mary Helen and Elena, and currently we're discussing a lot of exciting things that go boom, actually. Rockets, launches, sometimes on accident, sometimes not. And if you have any other questions or if you would like to make a donation, you can always see it that same website again, yorku.ca/science/observatory. And if you are listening to this on the podcast later and want to join us live, just go to that website and click on the bar or any of the tabs for OPV online public viewing. All right, so we have one little extra bonus this week in space and astronomy history that I just had to sneak in because we're talking about famous launches. We have Mariner, we have Pioneer, we have an amazing famous launch center. But on the 5th of November 2018, there was actually a very significant thing that happened that relates back to this time. November 5th, 2018 was when Voyager 2 officially entered the interstellar medium. This was one of those missions where you just yeah, it's been astonishingly successful. It was also launched in the 70s, 1977, and it has been in space for a very long time. Voyager 2 was launched as part of the Voyager program. We had Voyager 1 and Voyager 2. Voyager 2 successfully fulfilled its primary mission of visiting the Jupiter or Jovian system, the Saturnian system, Uranian system, Neptunian system, and it was all done with that Neptunian system by 1989. And then it kept going and going and going. And as of October 2024, it is over 20 billion kilometers or 12 billion miles from Earth. If that's an incredible number to try to picture, just remember that Earth is 1 AU from the sun. And that's 1 astronomical unit. This thing has made it 138 and a bit astronomical units. So at least 138 times farther from the sun than we are. From its distance, the sun is a tiny, tiny speck. Probably doesn't look much different than any other star, maybe just a little bit brighter. Voyager 2 is still the only, and this is a scandal, the only spacecraft to visit the entire planetary systems of Uranus and Neptune. It is, now in interstellar space, have got easily passed into that region some time ago. This is where we have something called the heliopause, which if you haven't heard of before, it's basically where the sun's sort of pressure from the photons, like I like to think of it as the sun's pressure from its photons are pushing out into the Milky Way galaxy, and at some point they stop becoming the dominant pressure. And the heliopause is basically that point. This is basically the bubble of energetic particles and magnetic fields from our sun that make up our solar system. And Voyager 2 is on the other side of that. It is pretty crazy. It is current status extended mission, and boy is it extended. Um, that's understatement of the year. It's the only spacecraft to discover or to study all four of the solar system's giant planets. It discovered a 14th moon at Jupiter, and it's of course Uranus and Neptune, only thing to go by. And it discovered uh, at Neptune 5 moons, 4 rings, and if you haven't had your icy outer solar system fix, a great dark spot on Neptune's surface. Oh my gosh.
Yeah,
Um,
yeah, the Voyagers were quite a fascinating mission series, both of them, but Voyager 2, I mean, it's interesting when you teach the planetary sciences because you get to Uranus and Neptune and it's like, well, this is about all I can tell you. And students look at you like, why? And I'm like, well, we've got a small problem. We haven't visited them again. I mean, Hubble images gave us some. They actually looked for the Great Dark Spot with the Hubble and couldn't find it. So they figure it had blown itself out in the years between when Voyager 2 passed and when Hubble looked at it. But it's like you said, it's shocking that we've sent New Horizons out to Pluto and out to the Kuiper Belt, but we still
yeah.
haven't gone back to these two. So yeah,
Well, and
the
there's
question
there's
why?
so much to discover there, and especially, I mean, Uranus and Neptune have so much going on. We already know that, of course, we've been talking about Europa and tidal heating. We know that tidal heating can heat up, some of these icy bodies enough to create liquid water. And it's just amazing that we haven't
Yeah.
gone back with at least an orbiter.
Yeah. I mean, if you look at some of the Voyager and some of the even I don't know if Hubble's gotten much in the way of pictures of one of Neptune's biggest moon, Titan. Um, or
Yeah,
Triton, sorry, mispronounced that. Triton's fascinating because if you look
yes.
at the surface, it's being resurfaced. It's too smooth. Something has happened. Like there's almost no impact craters over large swaths of it. So it's an interesting question as to what is going on, and yet there's never been much in the way of interest. I think part of the thinking probably in the 70s and 80s was, well, they're just smaller versions of Jupiter and Saturn, so why bother? But I think in recent years they've come to understand that the composition is very different from what you see from Jupiter and Saturn. There's been a real division into sort of gas giants and ice giants. So the question is, why haven't we started to think about going
Yeah,
back?
yeah. Well, and I mean, the thought has definitely been there, I think, and a lot of people have advocated for it. I mean, I would recommend everybody to check out some of the new JWST images, actually, from Neptune, and Uranus, and it does obviously capture some of Neptune's moon Triton, but at this distance, even JWST can't really get the resolution that you need, and you've got to send an orbiter back. I'm convinced, but I obviously am not in charge of the funding, so I think this would be a extremely easy win for um, anybody who wanted to go and spend a couple billion on something that would be, you don't need to do any put AI into your search engines. Just do one of these missions and you'll get so much better results. Anyways, we should go on and do some news items before we run out of time, but it's been very fun. I just quick reminder to folks that there's no in-person tour this week due to the RASC event on campus, but we are having a in-person tour per regular next week so that everyone can sign up for free over at the Allan Carswell Observatory. And yeah, let's look at the news items. You have a pretty cool one actually that gets us back to talking about Voyager 1 and New Horizons.
Yeah, so staying in the outer solar system, I mean, with Voyager 1 and Voyager 2, the engineering challenges of keeping them going has been, it's amazing what they've managed to overcome. I mean, Voyager 1 now, in order to get a signal back, you're talking 23 hours one-way
Yeah.
travel. And Voyager 1 has been experiencing communication problems and the what they call the X band uh, radio
Yeah.
shut down a few days ago, but they managed to recontact it using what they call the S band, which is a different wavelength communication, and it's it still works even though they hadn't used it since 1981, and they've managed to reestablish communication. Now they don't want to switch back to the X band because they're not entirely sure why it shut down in the first place. But the fact that, there's enough redundancy that you've kept this thing working for, what is it, getting close to 50 years now?
Yeah.
It's,
Yeah.
like that's pretty spectacular. So it's still going. They lose communication and they reestablish it, but that's what's happened with Voyager 1. So they're still talking to it. The New Horizons is even more interesting because it's now gotten far enough out that it's finding stuff we didn't know about. They found a bunch of possible dwarf planets far out, and they're not entirely sure if this is sort of a whole different group of objects. It's part of the Kuiper Belt. Is there sort of another belt out beyond the Kuiper Belt that we just couldn't see from Earth, but now that New Horizons is out there, it's finding evidence of. So it's raising a lot of interesting questions that hopefully it'll be able to answer as it gets further and further away, because New Horizons was designed to keep operating out there. Um, it's not as far out as the Voyagers by any means, but it has the instrumentation to sort of study those far out objects that they didn't really plan on with the Voyagers, because they didn't really even know the Kuiper Belt existed when the Voyagers were launched. So New Horizons is still doing some pretty exciting and interesting science, and finding out just what lies beyond the planets. It's not just empty space out there. There seems to be a lot surrounding our solar system that we didn't really know about
Yeah.
prior to
We
this.
we couldn't see it, right? It
Yeah.
was too low albedo, and too small. And the question is, like, how many of these dwarf planets might be out there? And like, there is obviously a limit as to how big they could be, without, affecting gravitationally the orbits of the other planets. But you could get some pretty darn interesting stuff out there, um, uh, you know, in the right place, and who knows how far away, right? So it's of course, when it went past Arakoth, we all got some beautiful images off of that. But just keeping it looking for things. And I think they are they still hibernating it, or is it back on again?
Well, they must have had to have it back on for a bit in order to pick up some of the results it did, because it's actually sort of sending data back. So they may be sort of bringing it out every once in a while. Because I know after Arakoth, they were trying to see if they could find another target that, was within reach with the course corrections they might still be able to do with the space probe. But I hadn't heard anything further about specific targets. But this was looking at the environment out there, a combination of dwarf planets and dust and a number of other things that it's turning up. Now, from the time it observes to the time this gets published, there can be a gap of, several months, but it's interesting that, it's still sending back science, and they're still hoping they can find a target out there, whether it's a dwarf planet or something else like Arakoth, to take another look at, because it's like I said, the mission is still functional. So you can find another target, you still do some pretty neat science. So
Yeah, yeah. And I mean, of course, resolving Pluto for the first time was pretty darn amazing, in and of itself. And if you could find another target and get to it, who knows what they would be able to find out there in these icy outer reaches. I mean, and it's worth remembering, out of this distance as well. This is not as far as you say as Voyager. But even so, the sun out there is very, very tiny. You're getting almost no heat at all from the sun. Any kind of heating you do would need to be probably gravitational heating or residual heat from your planet formation.
Or radioactivity is the other one out
Yeah,
there. If there's enough of a
radioactive.
rocky body, that's another possibility. But the interesting one is, I mean, when they talk about Triton around Neptune, I mean, one of the theories is Triton actually came from somewhere out there, and it wasn't formed with Neptune, but is actually a captured object, which
Yes.
is part of why its orbit is so odd. Um, and if you had like a number of small dwarf planets together, would they potentially actually create enough tidal heating on each other if you had a grouping of them? So it's the more we look, the more interesting things we find, and the more unexpected things you find.
Oh yeah, absolutely. And it'll have some time until it leaves the Kuiper Belt. I think that's
Mhm.
not going to be until 2028. So this is definitely one to keep an eye on. And I think we probably better stop there because we are running out of a little bit of time. So recommend everybody to go and read up about your favorite space missions, and also make sure you check in with Voyager 1 and New Horizons every once in a while. Everyone, thank you very much for joining us. You have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Mary Helen Armour and myself, Elena Hyde. You can always connect with us on Instagram at YorkU Observatory and Facebook at Allan Carswell Obs. And you can see our website for show note, contents, and updates and contact info all at yorku.ca/science/observatory. Thanks for tuning in to York Universe. Clear skies and have a good night.